Hey guys, just want to do a couple more practice problems for you. The ones from the notes, limits day 2, about infinite limits. So this is the first slide. I think it's on the 3rd page of the notes, but it's certainly in there. This is a pretty typical problem. It's kind of like the ones I did where I said we think about the limit is, this says negative infinity, but I want you to think of it as being positive infinity. I just don't want to worry about the negatives right now. Just do that. Same with this one. We're just going to think about x approaching positive infinity. So we said that we look at the, not equal. We look at the degree of the numerator and degree of the denominator. So the degree of this term is 1. X to the first is the biggest power of x. And we saw in the notes that really the top, as x approaches infinity, the top really becomes the square root of 2x squared. Like any term that's not as big as x squared just doesn't become very meaningful when x gets very, very large. So this is the same as, as x approaches infinity, this term approaches root 2x squared, which we can simplify as square root of 2 times x, which tells me now that the degree of the numerator is also 1 because that's x to the first here. So when the degrees of the numerator and denominator are the same, we look at that ratio of a over b of the leading coefficients. And here the leading coefficient of the numerator is root 2. And the leading coefficient of the denominator is 1, and you just get root 2. So this limit, as x approaches, remember, positive infinity is equal to square root of 2. Down here, we have a similar situation where we have something that's easier to find the degree of on top, something maybe a little more tricky on the bottom. Similarly, the degree of the numerator now is 1. And degree of the denominator, we maybe think about it the same way we did the one above it, where we say, as x approaches infinity, x squared plus 2 approaches x squared. And what that means is the 2 becomes less and less important as x gets bigger and bigger and bigger. So this thing approaches root x squared, which we know is equal to x. So the degree of this, also 1. So just like up here, when the degrees are equal, the limit is equal to a over b, which in this case is 4 over 1, which is equal to 4. So that's how I would do the first one, or the first couple. Those are the ones with the square roots. These are just kind of, the rest of them are more generic. Well, they're more just like limit questions. This one is very much like one we did on the, I did on the whiteboard, where we have a limit at infinity. Remember, these rules are for limits at infinity. And we have a polynomial on top and a polynomial on the bottom. So I just take a look and I'm like, what's the degree of the top? The degree is 3. And here, the degree is also 3. Okay, that's not hugely surprising, but whatever. So when the degrees are equal, I think about what a over b is, leading coefficients of the numerator and denominator. That's 3 over 1, which is equal to 3. One thing to just kind of be careful of is these aren't always written like in descending order like they are here. So this could have been 3n cubed minus 5n to the 4th, which would make the degree up here 4, and it would change the answer. Just be careful, look at all the terms and not just the ones in front, because sometimes it's not written in that nice convenient order for you. So I think that one went pretty quickly. This one is going to be a little more tricky maybe for you guys because of the format, but we can look. Here's a graph of a function. You can see it looks a little bit like the ones we looked at the other day. There's like some holes and there's a jump right here. And it asks you basically 4 questions. The graph of the function is shown above which of the following statements is false. A question like that, you just run through the statements until you run into one that's false. So starting with the first one, I say the limit as x approaches 2 of f of x exists. So does it? To answer this question, I look at the graph and I say, as I approach 2 from the left and 2 from the right on the x-axis, do the y's approach the same value? And so if I approach 2 from the left on the graph, y approaches 2. I approach 2 from the right on the graph, y approaches 2. This limit does exist, which means this is not the right answer. It says which of the following statements is false. Excuse me, this statement is true. I'll write a T there just to remind you. Limit as x approaches 3 exists. Now as I approach 3 from the left, y goes to 5. And as I approach x equals 3 from the right, y goes to 5, so that exists. Limit as approaches 4 exists. All right, this is going to be the one that's false because I can see as x approaches 4 from the left on the graph, the y approaches like 1 point whatever, 1.9 or something. And as x approaches 4 from the right, y approaches 4. These are not equal. Therefore, the statement is false. And therefore, this is the correct answer. Remember, the question says which of the following statements is false. Limit as x approaches 5 exists. I mean, that's right here. You can see that as you approach from the left and the right, the y approaches 6 both times. So this problem is a lot. Hopefully, maybe not, but I'm happy to run through them like this. But this one ought to be a little quicker. You're like 2, yep. 3, yep. 4, nope, there's a jump. So we know that either jumps or infinite discontinuities are the things that make our limits fail to exist. So this is the last one. This one's a little different, and it's probably a little bit harder. But remember, it's all just limits. It says the limit is the vertical line x equals 2 is an asymptote for the graph of f, which the following statements must be false. Oops, that's a terrible line. It's not any better. One last time. That's better. So it says a vertical line, x equals 2. So pretend like that's x equals 2. It's an asymptote which of the following statements must be false. So I don't know. I mean, the limit at infinity, these two limits at infinity, like knowing that x equals 2 is an asymptote doesn't tell me anything about what happens as I move left and right. So like these don't really have any bearing on this problem. Like there's no way to tell one way or the other just given this information. This thing could look like anything. So sure, it could go to the horizontal asymptote could be 2, or it could have no horizontal asymptote or something, but I don't know what it looks like. So really the concern is going to be what happens at 2. So is it possible that as you approach 2, it equals infinity? Yeah, that would be like it shoots up this way, both directions. Or, so this could for sure be true. Like it could look like that. I would say that this limit doesn't exist because it approaches infinity, but this is saying as x approaches 2, it approaches infinity from both sides. That's certainly true. That certainly could be true, excuse me. And then this one says negative infinity, which is the same thing, just going down. The only one that has to be false is this one. Because if this is an asymptote, like f of 2 can't approach 0 from both sides. Like it would have to look like, the function would look like this. And like this is not the behavior of a function at an asymptote. We know that if it's a vertical asymptote, as x gets close to 2, y either shoots all the way up to infinity or all the way down to negative infinity. And for this limit to exist here, it has to, like both sides have to go towards 0 when it goes towards 2, and that's not what's happening here. So this one's a little, like I said, it's more conceptual, it's more difficult. The only part of limits at infinity we used was crossing them off here at the bottom. So feel free to ask me questions about this one. If you don't get it, I'm happy to go over it again or answer any other questions you might have. So I think those are all the problems in the notes. And you guys have homework problems, which look a bit like these. So get after them, guys.